Good morning. Once again, this is Professor Grenfell, and today we are going to go over different types of graphs for organizing and presenting data. So this is, what type of statistics would this be if we are organizing and presenting, visualizing data? That's right, descriptive statistics. That's excellent. I heard you playing along at home. Okay, so the types of graphs are histograms, frequency polygons, and ogives. Well, that's a quirky one, that one, ogives. And so here, maybe with the exception of the frequency polygon, actually the frequency polygon, that is one cue that ties all of these graphs here. All three of these are related to our frequency distribution here. Now the first one we'll start out with is the histogram, and this is actually, I was when I was talking about the frequency distribution in the previous video, I was actually drawing a sketch of a histogram, because for me, I guess I'm such a visual learner that I couldn't really describe the chart of the table without giving you the picture version of what it is. And that is exactly what this is. It is merely just a bar graph of the frequency distribution. So that's how I spell frequency distribution. Along the x-axis here, you're going to have your class, well, your classes delineated out. These lines, these demarcation lines, are actually at the class boundaries, not the class limits, but the boundaries. And then what we're going to do is, well, according to whatever the frequency is for these classes, let's kind of just, let's say 2, 8, this one's maybe 18, this one's 13, something like that. Right. And so what we would do is we would say, okay, this class had 2 in it, its frequency was 2, and so we'll just go ahead and make a little bar above this graph that has a height of 2. Okay. For this next class, we see its frequency is 8, so that means we had 8 occurrences of data values that were in this bucket, whatever its limits or boundaries were. I don't remember, but it is going to be 8 tall. So there it is, approximately. And it's not necessary to put counting lines across. I was just trying to make sure that these were reasonably, to scale. I don't want my graphs to be misleading. And, I just wanted to kind of sketch in the rest of it there. So notice this one that's 18 tall, it is, kind of extending up the scale. So maybe let that be a warning to you. Maybe plan it a little bit better where your graph is going to be situated. Okay. Do as I say, not as I do. The next is going to be a frequency polygon. The frequency polygon now is what I would call a stick graph. I put that in quotes because I'm not exactly sure if that's an actual term. I say it all the time, but I don't hear anybody else saying it that often, so I don't know if it's a thing. But what I mean by this is kind of, something like a connect the dots type picture, where you have a straight line connecting to one point to another point, and then joining from that point and connecting on to another point. You have another straight stick, a stick line. So this is a stick graph of the frequency distribution. And so in order to create this, first off, along the x-axis, in black here, in these black tick marks, those are the class limits, no, sorry, the class boundaries, technically, because they are but right up one against each other. And then in orange, here, these are actually the midpoints of each of these classes. So I think you might have skipped over that from section 2.1, but we'll go ahead and cover it this time. All right, and so the only kind of difference here is that instead of making a solid bar like this, this first one, instead we're going to use a little dot, right? So we're going to put this dot at a height of 2 above here. Oh, so by the way, I am recreating this histogram just using a frequency polygon, but it is representing the same exact set of data, the one that we're going to actually look at in just a second. So here, this class here, remember, was having 8 in it, and so we're just going to go up to a height of 8 right there. Put that one. This one is 18, so maybe a little bit off the scale. Here, 13, 7, 1, 1, so forth. Okay. So basically, after we've gone ahead and marked these off, where these heights are for a graph, right on the 13. And we're just going to go ahead and say, look, well, right there, technically, remember with the cumulative frequency, if we drop down to whatever that lower limit is, there's nothing that's there because all of our data fell to this side of the lowest value. Okay. So that was a height of 2, and then we're going to connect up to this next dot there, and then we're going to connect up to this one here, and it is supposed to be a straight line. So I mean, you can kind of make these points a little bit bigger, so the graph looks a little bit better. It slopes down kind of like this and drops off like such, and then kind of sort of evens out like that. And then you can say after that it drops down to nothing. That would be our frequency polygon. So this last one is pronounced ogive, or plural, it's ogives. It's not ogive or ogives. And these are, you can think of them as the frequency polygon. I'll spell it fric poly. Frequency polygon for the cumulative, yeah, I had to sound it out there, cumulative frequency distribution. So remember, the frequency of the cumulative frequency distribution was the set of all values lower than a certain boundary value. So here we had 0 lower than the lowest boundary, and then we had a total of 2 that were lower than that, and here 8 in between this boundary and this bound, 2 before that, and none before that. So here we had a total of 10, and so on and so forth. And so we'll take a look at, instead of the regular frequency distribution, we'll just look at the cumulative frequency distribution and then create a, remember, another word for frequency polygon is stick graph, but I don't know if that's a real term. If it helps you remember, then yes, it is a real, precise, mathematical, technical term. Okay, so let's go into, okay, so we're going to jump on into example 2-4. And here I've just gone ahead and embedded a little photo of the finalized frequency distribution for the problem pertaining to record high temperatures. So this was the one that we got from 2-2, example 2-2. So in example 2-4, we will be creating a histogram. So let's jot that down, histogram. Save it. Okay, so here, I'm going to have to kind of keep referencing what these numbers are, the class values, or sorry, the class boundaries. So scroll up. The class limits are 100 to 104, 105 to 109. See, they don't overlap. The endpoints for the limits cannot be the same. 110 to 114, 115 to 119, 20 to 24, 25 to 29, and so on. Okay, so the boundaries are the ones that we're actually going to mark on our x-axis. So those ones, starting with 99.5, we'll just go ahead and evenly disperse those throughout here. So I've gone ahead and filled in those boundary lines, and so yeah, we use the class boundaries to be the boundaries of the classes. And then, kind of as I illustrated above, we're going to make this one have a height of 2. This one has height of 8. And the next here is going to have a height of 18. And then 13 for the next one. That's what memory served. And 7 here for the next. Not that I was a perfectionist or anything, but I measured those with a ruler, just to make sure that it was right. So, and you know, just remind you to 8. Okay, 18 here, 13, 7. This one was 1. Sun. Okay. So let's move on now. Example 2.5 says what? Using the frequency distribution given in example 2-4, construct a frequency polygon. Okay, so that's the nice thing about this one. We have all of the data from the frequency distribution all nicely compartmentalized. Looking at this, just keep in mind, by the way, you cannot tell what the original data is. Now it is considered as grouped data, and it is in a grouped frequency distribution. So here are our tallies, here are our frequencies, and notice we've already got a graph of the frequencies. Now that is a representation of the frequency distribution. But here what we want is frequency polygon. Now the frequency polygon is essentially almost, gosh, I want to say it's the same thing, but you know, there's a small difference between it and the histogram. The frequency polygon is, like we said, a stick graph for the same frequency distribution. So we could, and I think I'm going to actually cheat and use the graph that I have right here for the histogram and just go ahead and superimpose the graph for the frequency polygon over it. But the first things first that we have to look at are the midpoints. So here we're not going to be using the class boundaries, we're going to be using the class midpoints. So the formula to calculate the midpoint is going to be as such. It's the upper value minus the lower value divided by 2. So this applies for the limit. You could say the upper limit minus the lower limit, or you could say it works with the boundary as well. So just remember, if you're using the limits, it's going to be the upper limit minus the lower limit, and same for boundaries. These would have to be both the boundaries. So here, you could say it like this: U subscript L for, make sure you know it's an L, not an I, for lower, or sorry, this L is for limit, okay, and this L, that's the lower subscript limit, okay, or we could say M is equal to the upper boundary minus the lower boundary. All right, so I'm going to scroll back up to the top, take a look at our frequency distribution, and we'll just take a peek at this first one here, the first class, and we'll look at the class limit. So midpoint is equal to, this tip of mine, by the way, whenever you are trying to utilize a formula, write it down from memory, okay? So I know I have to calculate the midpoint. I know I might be staring at it on a separate sheet of paper, but I cover your eyes and write it down, okay? So it's the upper limit minus the lower limit. So there's where the subscripts come in. So here, then plug in your values. So the upper limit for this first class is 104. The lower limit is 100. So in the numerator, we have 104 minus 100. We're going to divide that whole business by 2. So we get 4 divided by 2, and that is 2. I have dismay. Okay, well here's the thing. I should have practiced my own advice, and once I wrote it down from the best of my memory, I should have maybe double checked it. I got a little bit too confident. So let's go back to where I wrote it down originally, and let's fix it. They included the formula at the very beginning of chapter 2, and I don't know if we ever really used it there. So it is, here's the crucial difference. Just one small typo. Yeah, that's it. It was a typo. Can throw off your whole calculation. So yes, this makes more sense. Okay, yeah, I should have been thinking about this. If we have, let's say, the upper value is this one and the lower value is this one, so we're trying to find the midpoint of this class, right? What do we do here? We take the upper plus the lower and then divide that by 2. So that's called the average of these two numbers. Yeah, I should have thought about the formula sheet, whether it made sense. No, I didn't do either of those things. So here, got to get the formula right. And this is the U subscript L plus L subscript L, all divided by 2. So this should be 104 plus 100. This is 204 divided by 2. So that works out as, where's that business here? So what did I say it was? 204 divided by 2. So it works out as 102. All right. And actually, you know what? Look, if we do it like this, the midpoint equals U subscript B plus, let me get the right, yeah. L subscript B all divided by 2. Yeah, it makes sense, right? We want to find the middle. We're meeting in the middle, so we're just going to take the average, right? Of 2 numbers. That would be, oh, now this one, notice if we're using the class boundaries, Well, we got to plug in these stupid numbers. So we got 104.5 plus, and remember, plus, mainly reminding myself here, but you know, you might be encountering similar sort of hiccups along the way. Okay, so I've got 104.5 plus 99.5. And the observation here is this is just half a unit beyond 104. This is half a unit below 100. So the class limits and the class boundaries, if you average them together, whether you average 100 plus 104, and then divided by 2, or 99.5 plus 104.5, right? So this extra 0.5 that we added on there adds on the extra 0.5 that we took away from the 100 over there. And so obviously we're going to get the same exact thing, better, right? They wouldn't give us two different calculations that yielded different results. Okay, so that is exactly how we're going to do this. We're going to use the class limits whenever possible. Don't mess around with class boundaries other than what? To make sure that you mark the correct labels on your histogram, all right? And then similarly, to make sure that we mark the correct labels on what? Our frequency distribution, or sorry, a frequency polygon, we're going to go in here and label what the exact midpoints of each of these classes are. And now it's scrolled back up, and so here I prefer to do the calculation with these nice round numbers rather than these ones that have a decimal. So we're going to add 105 plus 109 and then divide by 2. Sloppy. I should have written it down, the formula, and then used it to just make sure I'm doing it correct. But what do we get here? We get 214. 214 divided by 2, and so that works out as 107. And let's see, is 107 right smack in the middle of 105 and 109? Yeah, that seems to make sense. Okay. And then let's see what's next. 110 to 114. Oh, well, 102 would be right smack in the middle there. Oh, and now look at this. It was 102 here. 107 here. Ah, shoot. What I say here, I messed that one up again. 112, right? And notice what we got here. We got a little alternating pattern. 2, 7, 2. What do you think the next one's going to be? What's right in the middle of 115 and 119? Yep, that's right, 117. So that's kind of nice. We figured it out pretty quick. So this is the set of all of the midpoints. We got 117, 122. Oh, I get it. We're just adding 5. What happened? Oh, wrong page. Okay, 127, and then 132. Okay. And so here, look, there's no data values, no items that are below 99.5. So right at the midpoint of each of these. So basically, it's just a difference in terms of the style of the graph. So right at the midpoint, in this case, 2 units above, we're going to have a little dot, and we're going to connect our line at 0, right here at 99.5, going up to a height of 2, right above the x value of 102. And then the next vertex here is located directly 8 units above 107. And so we'll connect this point to this point. And then similarly, this next one to that top point right there. And then to here, and so on, and so forth. And then this last part is flat across. And then there's nothing above 134.5, so it'll flatten down to the bottom there. All right, moving on to example 2-6. And so in this one, we are going to construct the ogive for what? The frequency distribution that was described in 2-4 and in 2-2 that we came up with in 2-2. So, well, the ogive is the stick graph for the frequency polygon, but for the cumulative frequency distribution. So what we have here is just the group frequency distribution, not cumulative. So it just gives the total number of values between each one of these. So here we can construct easily from the group frequency distribution the cumulative frequency distribution. We'll just say we have 0 starting out before we have any data. We have 0, okay, and then whatever is in our frequency column right here, we'll just go ahead and add. So we have 0 plus 2 is 2. Okay, we have a 2 over here, and 8 in our frequency column. 2 plus 8 gives us 10. 28, and then 41, and 48, and so on and so forth. And as you can see, we have those exact, the cumulative frequencies given here match up exactly with these ones here. And notice that the classes are a little bit different. So here, we're not using the midpoints, we're using the boundaries. Again, once again, we're using the boundaries, so that's like the histogram. And here we're starting off with less than the lowest boundary, and then every subsequent one is everything less than 104.5, everything less than 109.5, everything less than, and so on and so forth. And that's why we add all of the previous ones before, all of the things that came before are then summed up and added to. That's the idea of cumulative. So, by the way, the final is cumulative. So, this is the cumulative frequency distribution. And so let's go to the graph. And so this is the graph of the ogive. So here the points that we've graphed are above the boundary values, and this is the total number of values that are below whatever this boundary value is. And the last thing to notice is the ogive is similar looking to the frequency polygon. However, notice that it is always increasing as we go from left to right. The graph will always be moving upward. The changes here, so from here to here, right, where the vertical change, that is exactly the same as the value that is in the frequency polygon. So ogive, frequency polygon are very similarly related, and these are all methods of presenting, graphing the data. All right, let's call it here before the time runs out.